Please welcome Brian Lauer.
Thank you so much. All right, well, thank you so much, everybody. It is such an honor and a pleasure to be invited to speak here, and thank you for coming. And I learned something today. I always thought rocks were part of the curse. You know, we'd pick them out of our field because they hurt the machinery, but boy, those are some pretty neat ones. Who got some really neat rocks today? Yeah, that was pretty good. And then who saw the rhinos buried in ash yesterday? Oh, okay, good. Yeah, this is really a fun conference. And so a little bit about my background is I've got a ministry called Solidify Your Faith. That's my website, solidifyyourfaith.webs.com. And my goal is to help you solidify your faith in the Bible by looking at science. Because there's so much evidence that points to a creator and a worldwide flood, but it's being censored or misinterpreted by our government schools, museums, and media. And the results are devastating. You know, it's 67 to 90% of our kids, they stop going to church once they leave home. And they're leaving mainly because they doubt the Bible's true, and they began to doubt the Bible when they were in junior high and high school. And so there's a battle. And I encourage the adults to come to the battle talk tomorrow morning. It's rather eye-opening what the evolutionists want to do. And so to counter what they're doing in our textbooks, I've given creation talks from here to Florida at churches and schools and colleges and youth. This is the waterfront rescue missions, vacation Bible schools. I even got a booth at the fair last fall. That's a whole nother talk, talking to the people. And we'd have questions of the day. What came first, the chicken or the egg? And we'd talk about that, and we'd go on and spend time at campus, try and get Bible clubs going on campus. We did it at St. Cloud State. We got Grace Campus Fellowship going there. Up in Brainerd, we got Campus Bible Fellowship. And that was kind of neat, because they're on their own. They're an hour away, and I hardly ever get up there. And what they wanted to do was have a Bible study every week in front of everybody. They could have had a classroom and done it in private, but they did it right in the main building and the main part of the main place, and I was so proud of them. And we got a creation club going at Northwestern, because we have creationists come in every month at the University of Northwestern, but nobody knew about it. So we got a creation club going there so they can at least announce it in chapel. And getting a creation club going in at a college, there's a lot of heavy lifting. Got to meet the students, got to get the advisor, got to write the Constitution, got to all these hoops to jump through. And so what I'm trying to do is get a creation club in every community. It's a lot easier. You just need somebody who understands how important it is and is willing to do something, and a place to show a movie, really. We were showing our movies at the St. Cloud Public Library. You know, and and then we use that as a big commercial for the regional speakers that come in every month. And this is one of the talks that I gave at State College in Florida. And if you want to see that one, it's the third talk on this one. It's they gave the creationist the microphone, and it was so much fun. And this video is not a science talk. It's not a video talk. I think we have enough information. We really do. We need to start doing something with it. These are more motivational talks. Behind enemy lines, and then also get in the game. I promise you've never heard a talk like get in the game. It's like a halftime and a coach. And speaking of clubs, the Rotary Club asked me to give a creation talk. And I had 20 minutes to tell them whatever I wanted. So I squeezed an hour and a half talk into 20 minutes. We just flew through it. So if you want a brief overview for you, grab one of my cards. I've got a YouTube channel, and search the Hydriplate overview, and you get a real quick concept. And what did I want to do for them? I wanted them to change their perspective of how the earth got here. You know, we've heard billions of years, millions of years, all these things, all this, all over the place. I wanted to change that. Change the perspective, because once you change it, it's really hard to unsee it again. It's like this. Does anybody know what this is? You guys were not in high school physics when Mr. Wabicki drew that on the wall, were you? Or on the chalkboard. You kids don't even know what chalkboards are, do you? Yeah, but he drew this on the chalkboard, and he says it's a bear climbing up the other side of a tree. Can you see it now? You know, and if we color in the details, that's my artistic flair. So now when you see that, it's really hard to unsee it. That's the bear climbing up the other side of the tree. And so that's what I wanted to do with the earth. And I gave this talk at St. Cloud State. It was called Noah, What Caused the Flood? A theory with one assumption that explains 25 major features on Earth and in the solar system. And for all those people taking notes, this is it. These are all the notes I want you to take. Just write down these websites. rsr.org. It's my favorite website. If I want to learn about something, I just go in there and I search the topic. And then I'll hear him interview somebody who knows something about it. And he's funny. Really funny. And I was driving, and that's what I did all the way down here. You can buy a year of their shows for $35, and they're top notch. So that's all I listened to on the way down here, 8 hours, and I'm just learning so much. And rsr.org, and if you want to, rsr.org/HPT, that'll bring you right to the Hydriplate Theory. Mountains of links and places to go, and very important link towards the bottom, and I'll touch on that at the end. And then hpt.rsr.org will bring you to the 9th edition of this book. This book was a $30 book. It's an 8th edition, but it's out of print. Now it's over $100. That's a good book that increases in value as time goes by. And but you can see the 9th edition for free, hpt.rsr.org, and you can hear Walt Brown explain it in his own words. And he's going to say 10 miles deep. He's changed it to 60 miles, and you'll understand when I get there. And also on YouTube, go into Brian Nickel. He animates it so you can see what's happening visually, and his Grand Canyon talk is the best I've ever seen. And I've seen a lot of Grand Canyon talks and videos, and I learned so much in Brian Nichols. And then I've got mine, a YouTube channel called Solidify Your Faith. And I encourage you to buy the videos. You can see them for free, but YouTube can take them down like that. So I encourage you to buy the videos so you have them. All right, and this theory, this is it. It's the theory. It's all-encompassing. And it answers a lot of questions. But if you don't know what the questions are, the answers aren't going to mean anything. So we're going to fly through these questions. Put your pens down. You won't be able to keep up. Just sit back and just trying to comprehend what's happening here. So question, how do marine fossils get over 5 miles high, in the Mount Everest, above sea level? And what causes a mountain to rise? And that's what I love about this theory. He comes at it from an engineering perspective. And what's the mechanism? What's the force? What's the energy to raise a mountain? And what formed the Mariana Trench, 36,000 feet deep in the Pacific? That's deeper than Mount Everest is high. And why are the trenches mainly in the Pacific Ocean? And why is the Pacific so much different than the other oceans? It's got 40,000 seamounts. These are volcanoes a kilometer high off the bottom. Why aren't they everywhere else? What caused this mid-oceanic ridge? A 46,000-mile mountain range going around the whole Earth at the bottom of the ocean. What caused that? And why are the mountain ranges parallel to this ridge, the Mid-Atlantic Ridge? Why is that? And how did the 90 East Ridge form? It's a 3,000-mile crack in the Earth that points directly to the Himalayas. How does something straight like that form? How does a mountain range form? By stretching it in 2 directions. And you can see these are vertical cracks, horizontal and vertical. They're straight. That means they're tension cracks. Those rocks were getting pushed apart, and then they cracked, and then the pressure released. Most mountains come together by compression, and they rise up. And we'll talk about that a little bit later. And why are there plateaus next to most of the mountain ranges? And it's what mechanism would force a large volume of low-standing continents to rise rapidly a mile in the air? And it's a double-sided mystery because the Colorado Plateau seems to grow downward and upward at the same time. How does that happen? What about the inland seas? What forms them? And where did the sediment come from? That averages a mile deep on the continents. And how come if it doesn't have carbon in it, and like limestone, it's 65 parts granite and 35 parts basalt? Why does it have that ratio? And how did it get cemented together? You can have sand out there, but that's not turning into sandstone unless it's mixed together with something like calcium carbonate and quartz. How did it get so evenly mixed? And how do you get continental layers? Anybody ever been to the Grand Canyon? Okay, those layers don't just stop there. Those go everywhere. They're continent-wide. How do you lay down something like that? And the evolutionists say, the present is the key to the past. Present processes explain everything in the past. And Randy Galuzza says, if I was in college now, I'd be asking them, what present process lays down continental layers of sediment? What present process is making fossils all over the world? Something was different in the past. And then Tim Clary, this is the Zooey mega sequence. That thing goes all the way around the world. These layers are worldwide layers of sediment, not just continent-wide. They're worldwide. How does that happen? And how do canyons form under the ocean? You got submarine canyons at the end of most of the major rivers, like the Congo and the Ganges. And then how does a little Colorado river cut a canyon 18 miles wide? I mean, that's probably the next town over. How does a little river cut a canyon that wide? And where did all the limestone come from? Because when limestone forms, it releases some carbon dioxide. And there's 60,000 times more limestone in the earth than carbon dioxide in the atmosphere. And Walt Brown, he would meet every week with Bob Dietz. He's the guy that coined the term seafloor spreading. And he asked him one time, hey, where'd all the limestone come from? And Bob says, beats the blank out of me. Yeah. They couldn't explain it. And then the Grand Canyon. What caused the side canyons? Just as deep as Grand Canyon, but there's no river. Those box canyons. What about barb canyons flowing the wrong way? And then that big funnel. Once you see that funnel, you can't unsee it. And where'd all the dirt go? A guy used to give tours there, and he'd say, yeah, I dug that. And the little kid asked him, where'd you put the dirt? And that question haunted him the rest of his life. It's like, where did the dirt go? There's 800 cubic miles of dirt from the Grand Canyon that are missing. And that's nothing, because they had to scrape off 2,000 cubic miles above it before they could start cutting the canyon. Where'd all that dirt go? How did mesas, buttes, and spires form? And how about petrified trees? How did that happen? And how did the lineaments form? Now, lineaments are straight line features on Earth, like a fault, straight. And that's kind of like, what were we talking about that was straight? Those tension cracks are straight. So we're going to talk about that. How does a canyon form under 2 kilometers of ice in Greenland? How do you get lakes with liquid water under 2 miles of ice in Antarctica? Especially when it's below freezing in the summer there. How does that happen? And how does the South Pole says it's mostly covered by ice, but fossils show there are crocodiles, dinosaurs, and palm trees once lived there. You know, if it was warmer, yeah, maybe the dinosaur and the crocodile could live there if it was warmer, but how are you going to get a palm tree to grow where it's dark for 4 months of the year? And that doesn't make sense. And then on the other side of the world, you got snakes and tortoises and alligators and shrews and stuff growing in permafrost? And that doesn't make sense. And the mammoths. Who's heard about the frozen mammoths? Okay, yeah, they're frozen in permafrost, and there was one of them that was really special. What was special about that one? He was frozen standing up. Do things stand up when they die? No, this thing was buried alive, flash frozen. It still had identifiable food in its stomach. How are you going to flash freeze an elephant? It has to be like 150 degrees below zero to flash freeze them. And how did it get so cold so fast? And then how come they never thawed out? Very, very interesting questions. And what caused the Ice Age? Evolutionists have 40 theories, which means none of them work. And the neat thing is, I saw this. It's hard to find a picture of the glacier. When I saw it, I was jumping up and down. My wife can attest to that. But look it up there in Alaska. What's missing in Alaska during the Ice Age? Do you see that? Ice. It's permafrost up there. They didn't have ice in the Ice Age. Same thing in the Siberia. They had permafrost. My son went to Pensacola Christian College, and his roommate was from Inuvik, Northwest Territory, Canada. So he's above the Arctic Circle, where there's permafrost. I said, well, how do you do your pipes? I mean, we put our pipes in the ground so they don't freeze. Your ground is frozen. How do you do that? And he said, we have utilidors, where they're above the ground. You either drive under them or drive over them, but they're heated so that they don't freeze. And then it's dark, and then it's light, and that's where he is now. He was in Florida. And how do redwoods grow in the permafrost north of the Arctic Circle? And these things are huge, 90-some feet. And then they got special isotopes in them. They have a different ratio of oxygen, which brings us to deuterium. Hydrogen is a proton and electron. Deuterium is the proton, electron, and a neutron. And how come the comets have twice as much deuterium as the oceans? If all the oceans came from comets, they should have the same amount of deuterium, but they don't. And this is a physics question. How do you fuse past iron? This is one of the greatest unanswered questions in physics, according to the U.S. National Research Council. How do you fuse past iron? And that was back in 2000. And this guy says, we're made of star stuff. The problem is, we aren't sure exactly how the stars did it. And then why do comets have stuff from Earth? They're supposed to come from the Oort cloud, way far, 50,000 astronomical units out there. An astronomical unit is from here to the sun. So 50,000 times farther than the sun, that's where the comets come from, and so they should have all this other stuff. But yet we find stuff in them That's water, salt, silicates, limestone, cubonate, olivine, organics, bacteria, all that stuff. That's on Earth. And they're going to say that life, that the comets brought life to Earth. And you're going to see why that's backwards later on. And cubonate only forms in the presence of scalding hot water. How did comets contain materials only made in scalding hot water? There's no scalding hot water out there. I mean, much less liquid water. I mean, we're the Goldilocks zone. We're the place with water. And then how does an asteroid get a moon? It's really hard to get a moon, because if they're coming together, they might just speed up and zoop and go on the other way, or they might smash and break each other apart, you know? And they can't explain how Earth got its moon. They got 4 theories now, which means none of them work. And so there's some unanswered questions. And then you get these peanut-shaped comets and asteroids. How do you get that? They came together very gently, and this really bothers them. It says, it's a major mystery how 2 objects, each to the size of skyscrapers, could collide without blowing each other to smithereens. This is especially puzzling in a region of the solar system where gravitational forces would normally involve collisions of up to 4,500 miles an hour. Anybody ever play pool? Do those balls stick together or do they bounce off? That's what should have happened here, but it didn't, and it really bothers them. It calls them a major mystery. And how do chondrules form in meteorites? Meteorites are like melted rock or something. Electric charge was in there. They think it got hit by lightning. Well, how are you going to get lightning in outer space? And why is the near side of the moon so much pounded much than the far side? The near side and the far side are totally opposites. The near side has been pounded, a lot more earthquakes, lava flows, and the far side is just peppered. And how does that happen? It looks like the near side got shot with buckshot, which is very counterintuitive because the Earth protects the near side, just the Earth itself, and then you throw in the gravitational force of it. It'd be very hard to hit the near side, and yet that's where most of the damage is. And you would think it would be the outer side. And then how do you get erosion on Mars from water? These erosion canyons from water. And then the comets, you know, if they came in from the asteroids, that Oort cloud, it should be a 50-50 mix. They should all be going back, you know, there shouldn't be a dominant direction that they flow, that they're going. But 90%, 93% of the short-term comets, which is less than 100 years, they're all going the same direction as the Earth, prograde. And then the mid-period ones from 100 to 700 years, it's 70-30. And then when you get the long-term ones over 700 years, then it's closer to a 50-50. But if they all came in from the Oort cloud, it should be 50-50 all the way through. So there's a problem with that theory. And so this is my question. Why doesn't the moon orbit the equator? You ever thought about that? Most satellites, if not all satellites in the solar system, they go around the equator. Except for all the planets. We don't go around the sun's equator. We're off a little bit, which is hard on their theory. But if the moon went around the Earth's equator, we'd hardly ever get a perfect solar eclipse. But it's not. It's on the same plane as what the Earth is going around the sun. So I don't know. I don't know if this theory answers that or not, but I just throw it out there. So we've gone through a lot of questions. And if there was a theory that could answer all those questions in a coherent manner, wouldn't that theory be worthy of study? Right? Yeah, I think it would be worthy of great study. And the question at the end is, well, why isn't it? And we're going to show you how to figure that one out. Okay, so now prepare to color in the details. Again, this is my favorite talk. I love talking about Walt Brown. People call him today's Isaac Newton. He's just brilliant. And my goal is to get him the credit he deserves. And so Walt Brown, his background was, he went to West Point. He was an Army Ranger, paratrooper, went to MIT, got his PhD in mechanical engineering, sharp guy, taught at the Air Force College in Colorado. He ran the Benet Military Lab, which had 200 scientists, and dozens of them were PhDs. And he was the top dog. So he's a sharp guy. And he was going through South Dakota one time. And he heard on the radio that somebody claimed they found Noah's Ark on a mountain. And, but going through, anybody ever drove through South Dakota? All you do is count the wall drug signs, right? Yeah? And so there's nothing to do. So he just started to kick it around in his head. Well, if they found an ark on a mountain, Well, that would mean that the whole world was covered with water to get an ark up on a mountain. And if the whole world was covered with water, that means that a whole bunch of plants and animals got buried in mud and turned into fossils. And he said, wait a minute. If fossils are evidence for the flood, where's the evidence for evolution? And he started to ask his colleagues that question. What evidence do you got for evolution? And after 2 years of asking his very well-educated colleagues, he didn't have any evidence. And so he became a creationist. And then he came up with this theory. And I love, this is Bob Enyart on the right, Walt Brown's this way, Bob Enyart's that way. And Bob and them guys, they do radio interviews, and that's what colored into my perspective of the world. It was Walt Brown Week. Go into rsr.org, search Walt Brown, and he just explains it out there. It's like, oh, the world makes perfect sense now. And some of the things are very high on Google's lists, you can check that out. But these are the things. I mean, this book is a $30 book, brand new. It's out of print. How much do you think it's worth now? $100. That's the Walt Brown Week, the Hydriplate Theory. And this Jane Albright, we'll talk about her at the end. She critiques all the flood models. This is Brian Nichols' YouTube channel. And he talks, this is an all-encompassing theory. Talks about the origin of comets, the origin of radioactivity. If everything was very good, is it good to have uranium on the Earth? That could cause birth defects. So he explains, and we'll touch on it tonight, on how radioactivity could have been formed during the flood. And the neat thing is, I'm on the board at the Twin Cities Creation Science, so I get to help schedule the speakers. And I got Brian Nichol coming in next month. Well, actually, it's Zoom, so you guys can listen to this. Brian Nichol, go into tccsa.tc, and then you can ask for a link, and you're going to be able to hear him explain the origin of limestone. And so, yeah, I'm pretty excited about that. And you can see it on YouTube also, but if you zoom in live, you'll be able to ask questions. Okay, so here's the Hydriplate theory. Now, keep in mind that theories typically go from effect to cause. There's cause and effect. We know what the effects are, and we're trying to figure out what caused them, right? So we know the effect, and we're trying to figure the cause, and we never really know because you can't go back in time to prove it. This is different. He sets up the cause with one assumption, just one assumption, and then lets the laws of physics go at it to give us the effects, and they match our world perfectly. And I gave this to a professor at St. Cloud State, because I know they don't have a theory for Grand Canyon. They got a bunch of theories, which means what? None of them work. And I said, you want to see a good theory for Grand Canyon? Check this one out. And she had this for about 6 months. We talked for about an hour and a half, and she said, the science works if the assumption is right. I just don't believe the assumption. So what I'm showing you works if the assumption is right. And he's just got one assumption. So what's the assumption? He assumes that half of the ocean was inside the Earth at one time. That's it. At least, and I'm saying at least half of the ocean was inside the Earth. So just think of the Earth as this big apple. And the skin is made of granite, 60 miles thick. There's a layer of water about a mile thick, and underneath that is basalt. That's it. That's the only assumption. So how do you get the laws of physics going at it? You throw in the moon, because the moon's going to tug on the Earth. High tide, low tide we got now. It's also going to tug on the crust. See, back then the Earth wasn't broken into plates like it is today. It was a solid crust, the crust. And so it'd get tugged and compressed, stretch and compress, stretch and compress twice a day. And now if I had a wire up here and I go back and forth, it's going to generate heat. Same thing with the crust. It got hotter and hotter and hotter and hotter. Heat had to go somewhere. It goes into the water. Water gets hotter and hotter and hotter. It wants to boil, but there's no room to boil. So it keeps getting hotter and hotter, and at 705 degrees, 3,200 psi, it becomes what's called supercritical water, where it's not really water and it's not really steam. It's just like these individual air packets all over the place. It's not water, not steam, but whatever it is, it dissolves things like crazy. And it starts to dissolve the granite above and the basalt below, and starts to make these minerals inside that water. Starts making the limestone. Remember the carbon dioxide that got released? Well, it just got recycled into something else. And it makes quartz and salts and silica. Some of these are the cementing agents that we're going to need to cement sand into sandstone. So it just keeps making these elements and minerals in that supercritical water, and so there's sediment building up inside that chamber. And And then eventually, the chamber gets weaker and weaker and weaker. The pressure gets more and more and more. Walt Brown says he thinks, under 60 miles of granite, can you imagine the pressure that's under there? He says it's 370,000 psi. Just tremendous pressure, hotter and hotter, more and more pressure. Eventually, the crust of the earth gets really weak, and it cracks. And the crack just rips around the earth at 3 miles per second. And so in 2 hours, it goes all the way around the earth and then comes back together on itself. And people say, Brian, come on, if that happened, wouldn't it leave a mark? And I say, yeah, it did. It's called the mid-oceanic ridge. He thinks that it ended where that black circle is because it kind of ends on itself, and then the water's just going to keep going. So if you run the movie backwards, he thinks it started up by Alaska. And then it just came right on through and just ripped apart, and the water's just gushing out like crazy. And so you're going to have 40 days and 40 nights of rain. That's one of the things. It can't rain, so they say it can't, but this is how it could. You had a fountain of water coming up. And the Bible even talks about it in Genesis 7:11, I believe. For in the 600th year, in the second month, the 17th day of the month, the fountains of the great deep burst open. Something to that effect. And the windows of heaven were opened. So the water's gushing up with tremendous force. Okay, so now what do we have here? We got a lot of that sediment coming up onto the continents, right? And we also have two cliffs 60 miles high. On Earth, you can't get a cliff 5 miles high because it's going to crush the rock beneath. Here you got 2 cliffs 60 miles high crumbling into that supersonic water and just going flowing, and that's going out, and that's why the ratio is 65 parts granite, so you get the stuff on the side and the stuff underneath, and 35 parts basalt, which is just on the bottom. Okay, and it just keeps coming up and shooting up and shooting up, and eventually the sediment's going on top of the earth, which shows, this is how we get the continental sediments, that all the sediment's going on, and then it gets sorted, but that gives you are the layers of sediment. That's where the sediment came from. A lot of it came from inside those subterranean chambers, and liquefaction can sort it. So you got all this sediment, and you got these big waves because the continents aren't breaking up the tides anymore. And the moon's still tugging, so you can have these huge waves, and it could be 200-foot waves, 300-foot waves. There's a lot of weight on that sediment, and then it gets released, and then the water comes up, and then it gets pushed down, and water comes up. Have you ever stood out in the ocean? Anybody ever just stood there, and your feet start going deeper and deeper? Yeah, you're getting sorted. You'll just keep going, and that's kind of what's happening here. It could sort out those layers so they're pancakes. And so Bob Enyart told those geologists at ICR, just consider liquefaction as far how those layers got there. And it's really interesting. Grand Canyon has slanted layers covered by parallel layers. How does that happen? If those layers are millions of years, how do you just shave them off and put new layers on? Well, Brian Nichols' video talks about that. And what's really interesting in that red wall limestone, that red layer right there, that's 500 meters thick. So if you do the math, and you do it, it's supposed to be 50 million years. That's how long that layer of red wall limestone took. Okay, 500 million, and it's 500 feet. So 500 feet is going to be 6,000 inches. 500 million years divided by 6,000 inches, it's going to be 8,000 years per inch. Okay, it's going to take 8,000 years for an inch of that sediment to rise, right? And you know what they find in it? Nautiloids. They're like a snow cone with a shrimp coming out. All right? And they're all pretty much in the same direction. And the thing that's real hard is 15% are vertical. And these are 18 inches long. So it's 18 inches times 8,000. It's supposed to stand vertical for all those years? No, I don't think so. So what else is happening? See, he doesn't think the Atlantic Ocean was there. He thinks that all eroded away. Africa, and they tried to put that Pangea together, but it doesn't really fit. But if you left line it up with the mid-oceanic ridge and leave a few hundred miles for erosion, it fits pretty good. And what happens is it's eroding and eroding, so now there's going to be less pressure on the mantle. So now the mantle is going to start to bulges up, and the continent plate starts sliding. Like if you had a railroad track, you lift it up, the train's going to start rolling. That's what happened with the continents. So you got North America and South America sliding to the west. You got Africa and Europe sliding to the east. And they keep going until they meet resistance or run out of water. And then they buckle up and make the mountains. That's why the mountains are parallel to the mid-oceanic ridge. And they buckle up. It's kind of like pushing a carpet against the wall, or a car accident. It's going to buckle up the hood. And that's how the mountains rose up. And you notice that the Rockies are twice as wide as the Andes. And I think it's because it slid over the mid-oceanic ridge. And so you get now this is a compression event. These are getting pushed together like crazy. And it's going to make coal and oil and metamorphic rock, because marble is limestone plus 600 degrees plus pressure. Diamonds are carbon plus 600 degrees plus pressure. And that pressure, extreme pressure and heat, they carbon date those, and they find carbon. So they have to be less than how old? 103,000, right? Dock rock. And then these are folded mountains in British Columbia. How do you get rock to bend? It had to be pliable at the time they got pushed together. And you can do this experiment at home, but I'd ask your parents, just see if you can ask to bend their favorite piece of china. Is that going to bend? No, it's going to break. And this is interesting. Oh yeah, Dan's got a rock. I was going to pass it around this time. But I think he's got a rock that has granite, and then it's filled in with white stuff. And I think the white stuff is quartz. And this is Gunnison Canyon in Colorado. And it got crushed together. And quartz is made of, the first thing that's going to melt in granite is quartz. And I'm thinking there's tremendous pressure, it cracked, and then that granite melted and filled in those cracks. And he's got a perfect rock. Go on the table on the corner and ask him to see this round rock, and it's crushed granite glued together with white stuff, the way it looks. And I think that's what happened here. And it's very difficult to get that white stuff intruded into that, the sides, especially the thin stuff. And the interesting thing about that type of rock formation, it's at the bottom of the Grand Canyon. That's the basement rock for the Grand Canyon. So that rock got crushed too. It's the Vishnu's schist. And then you got the rock, the mountains that slid to the side. You got the mid-oceanic ridge. And that's how you get a mountain range, by stretching it in two directions. It's bulging up. You zoom in on them, those are the tension cracks. There's pressure coming up from underneath, stretching the rock, and then when it finally stretches, it cracks, and then it releases the pressure. So these mountains are being formed by stretching it in two directions. It doesn't make sense from any other perspective. And then how do you get the plateaus next to the mountains? Because the mountains are a big mass on a small base. Big mass sinks in. Well, if something's sinking in, something's got to rise up. And that's how you got the plateaus rising up there. So it's hydraulics. What's the force? Hydraulics. Gravity is pulling the mountains down, and the hydraulic force is pushing the plateaus up. Okay? And it breaks them off on piecemeal. It doesn't push it all up at once. It piecemeal pushes it up like that. And so then you're going to might have some lava flow going up in those cracks. And if there's a big flood that comes through and it's going to try and wash all that away, it's going to hit the top, hard stuff on top, that lava flow, and it's going to flow around it. And guess what we got? Red Butte, Montana. So there's 1,000 feet of sediment above the Grand Canyon that got washed away before they could start carving the Grand Canyon. And notice where it is. It's right down near the Grand Canyon. And it's very, very interesting. I think this is this is key to putting together the puzzle. Okay, so now if the mid-oceanic ridge is rising up everywhere, similarly, something's got to sink in. What sinks in? The Pacific Ocean. That's why it's the ring of fire. It just got sucked in, a lot of pressure, a lot of heat, a lot of melted stuff. So that's where the lava, magma comes from. And that's how you got the Mariana Trench, almost 7 miles deep in the Pacific. That's why the trenches are in the Pacific. And it's just so much different in the Pacific. There's even a continent that sunk in. It's called Zealandia. Have anybody ever heard of that? About the size of India. They found evidence that land-based fossils there. So that's sunk in, and that was a prediction of Walt Brown too. You're going to find granite inside the Pacific Ocean. And that's what they found. Okay, so now the origin of the continental shelves. How come we got that slope? You got the continents, and then it slopes, and then it drops off. Why does it slope? Well, just think of it as a a fire hose or something. Just think of this as a hose. The water just doesn't come up all at once. The water, there's 60 miles of granite slamming down, and then the pressure is building up, so it releases and shoots up again. So this thing, they call it fluttering, keeps slamming down. So it's going to wear the nozzle of that end of the granite off more than the rest, and that's how it got tapered. Okay, and that's how you got the canyons in the continental shelf. Walt Brown says the continents were higher and they've sunk in. So the continents were higher, the water gushed off, cut the canyons, the continents sunk down, and then filled it up with water. And then you got Red Butte there. We'll take a quick overview of Grand Canyon. How'd that little river cut the canyon? It wasn't little at one time. And look at this funnel-shaped object. That's the key to the Grand Canyon. You see that funnel? It's 12 miles wide. Those cliffs are 2,000 feet high. All that 2,000 feet had to get washed away to start cutting the canyon. And what was happening, and the plateau is rising. So you got two huge lakes, Grand Lake and Hopi Lake. If you would dam up Grand Canyon, you get some big lakes, and roughly the size of Grand Canyon or the Great Lakes, plus all the sediment in the soil at the time too. Okay, so you got this mile-high lake ready to breach. What's going to happen when all that potential energy starts flowing over, going down? It's going to start washing away the sediment until it hits something hard, the Kaibab limestone, and then it spreads out. It didn't cut into the Kaibab limestone, it spread out and made that funnel. And then it starts to undercut Hopi Lake. And Hopi Lake's even higher, so you get more water gushing down, and that's what's washing away the stuff by Red Butte. Just all that stuff's getting wiped away, and that's what's left. Anybody ever been to Niagara Falls? Imagine something 20 times higher with 1,000 times the water flow. That's what he thinks what's coming out of those lakes. And water can do a lot of damage. This is the Guadalupe River in Texas. They got 30 inches of rain in a week, and it went over a spillway, and it cut a canyon 1 mile long, over 50 yards deep, and hundreds of yards wide through solid limestone rock. Water can do some really damaging stuff. It's been happened in 24 hours. Okay, and there was boulders the size of mobile homes were ripped up from the earth and mostly dry now. And so you got these big boulders banging down on the bottom of the riverbed, and just tremendous damage. And it almost happened with the Glen Canyon back in 1983. It almost went over, so they had water going through the spillway. You see that man right there? All that water is just gushing out of there. And then there's dirt started coming out, concrete coming, rebar just started coming out. The dam was starting to shake. They turned it down. And what happened? They had this thing called cavitation, where if there's a bounce or air bubble in that fast flow, it's like dynamite just blowing things up. And it made inside that steel reinforced concrete, it made a hole 32 feet deep, 40 feet wide, and 150 feet long. And so now they've realized we got to put air tubes in there to keep it from cavitating. And they figured out where to do that so that doesn't happen anymore. Had anybody ever been to Mount St. Helens? Okay. Yeah. So you had it doesn't take millions of years to cut a canyon. The mud flow blocked up Spirit Lake, and then in one day they saw it happened. It cut a canyon, 1,000 feet wide, 140 feet deep, in 9 hours. That was a mud flow. Catastrophic. They call it the mini Grand Canyon. And then there's an engineer's canyon on the right. Okay, and that brings us to petrified forest. Anybody ever been there? In Arizona? Why is that at the bottom of Hopi Lake? Walt Brown says that there was a lot of silica in that water. And when the water cooled off, that solution cooled off, it had to get out of the solution, so it went into the logs. And that's what petrified the logs. That's why it's at the bottom of that lake. Yeah, Jerry was saying, you can make it real quickly. Petrified wood. This one says you can make it in a laboratory rapidly by adding silica into it. And then Monument Valley, again, at the bottom of another lake, because that's what it is. It is at the bottom of a lake. There's 1,400 feet of sandstone underneath it now, but at the time of the flood, when the lake was there, it was just sand. 1,400 feet of sand, and the lake drains off, so the sand in the water rises up and starts to erode things. And if there's something blocking, it's going to go around the sides. And that's how the mesas, buttes, and spires formed. This is the bottom of a lake. And so how do you get a canyon under 2 kilometers of ice for Greenland? Well, the water flowed off, and then the ice age came and filled it up. Same way with the lakes for our Antarctica. And what's interesting about Antarctica, they find 91 new volcanoes beneath Antarctica's ice. So when they're freaking out about the ice melting, blaming it on climate change, it's like, no, there's volcanoes underneath there. Yeah, that's another talk. But how did the ice age come? Only the evolutionists can't explain it. So what is an ice age? So let's define it. It snows more than it melts year after year after year. That's an ice age. And so how do you get it to snow more? Well, it needs to be warmer. You need more precipitation. If it's too cold, it can't carry the moisture. It has to be warmer winters. But how do you get cooler summers? Well, that's because during the fall, the continents were higher at that time, plus a lot of volcanoes were going off, so there's a lot more aerosols in the atmosphere blocking the Earth's sun. So you got warmer winters, cooler summers, and 400 or 500 years of that, you're going to get the ice age. So why isn't there an ice age in Alaska or Siberia? Because it came down as rain. It was close enough to the ocean where it got the moderating effect from the ocean. It came down as rain, and then it went farther inland, and it became ice. And in 1815, Mount Krakatoa, that went off, and just one volcano. It lowered the temperature of the Earth so much that in northeastern America, they had snowstorms in June. And the ice formed in lakes in July, just from one volcano. So how does the ice age get, once it starts evolutionary-wise, once you start reflecting more and more of that heat away, it should never end. How come it ended here? Well, in those 400 or 500 years, the oceans are starting to cool off, so we're starting to get cooler winters, plus the atmosphere is starting to clear up, so you're getting more sun's heat. So it took 400 or 500 years to build it, a couple hundred years of that, and we're still, to a certain extent, recovering from the ice age. Okay, and I give a talk on that. There's a book on my table called Inconvenient Facts by Wrightstone. Everybody should read that because it destroys that climate change alarmism. He says freaking out over CO2 right now is like worrying about your gas tank overflowing when it's an eighth full. We've had 8 times more carbon dioxide in the past. And then he points out, hey, carbon dioxide is not pollution, it's plant food. More CO2 means more food. Less droughts, because they don't have to have their openings open so much to get the carbon dioxide they need, which dries out the plant and dries out the soil. If we had more carbon dioxide, and there's co2science.org or .com, you can see how much more wheat we'd get, how much more rice we'd get, how much more food we get. But you know what? The more solar farms we have, less food we have, less housing we have. So anyhow, moving on to the mammoths. Keep in mind, they're not Arctic animals. It's not wool, it's hair. And they don't have an oil gland to keep it waterproof. And they eat too much, 300 pounds a day, and they drink too much, 30 to 60 gallons a day. There's not enough food in the Arctic for them. They're temperate animals, where there's lots of food and lots of water. So how do you freeze something that fast while it's still standing up? How did it get so cold so fast? That's cold hail. Big cold hail. How did we get cold hail? Because some of the stuff was shooting up with such tremendous force, it went out of our atmosphere. Went up into outer space, got super cold, and came slamming down on the mammoths and buried them. And what's frozen carbon dioxide? Dry ice. And just buried them by, I don't know how many hundreds of feet, maybe, I don't know. But they're frozen to the ground. And so he predicts, you're never going to find oil under the mammoths. You're never going to find layers of marine fossil under the mammoths. He thinks that's the bottom of the flood. Okay, and so we'll see what happens there. And Bob Enyarts goes a step further. It's like, well, they could have got washed somewhere. That's a possibility. But he says you'll never find it under a standing mammoth. So it'll be interesting to see what happens. Okay, so that's how you froze them. How come they didn't thaw out? That brings us to the big roll. Okay, the northern hemisphere mountains and the southern hemisphere mountains pretty much cancel each other out, except for the Himalayas. Nothing in the southern hemisphere cancels out the Himalayas. So if you were to have a spinning top or bowling ball, put some extra weight on it, there's the weight on top, it's going to the side. It's bringing the top to the side, so therefore the side had to go to the top. So what happened was the mammoths were living in a temperate environment. The Himalayas was formed more towards the Arctic, And I think it moved 3,000 miles to the south. So you got mammoths getting fat and sassy in Mammothville, and then the Himalayans come up and they moved them up to Mammoth Chill. So they never thawed out. And similarly, it brought up the redwood trees, it brought up the shrews and the badgers, and brought up all that stuff to the top. It brought tropical palm tree down to the bottom in Antarctica. That's how you get these weird things that couldn't normally live there, where they're at right now. Okay? And so what happened in the Earth, when the Earth was rolling like that, the Earth is not round. There's a bulge at the equator. So as it's rolling, it's putting a lot of stress on that bulge, and that bulge cracks. That's how you got the 90 East Ridge. 3,000 mile crack pointed directly, you guessed it, at the Himalayas. And so that's how the 90 East Ridge was formed. And there it is. I love getting globes of what's on the bottom. At the bottom tells a big story. So is that why the moon doesn't, is that why the equator's different? I don't know. And what caused the inland seas? This is going to answer a lot of questions. What happened there? What formed these lineaments? Okay, how do you fuse past iron? That's all going to be covered, and going more in depth, Brian Nickel, the origin of radioactivity. It's very interesting. Okay, keep in mind granite, which is the bedrock for the continents, is made of 20% quartz. It also has feldspar, mica, and hornblende in it, but quartz is the key because it's piezoelectric. If you stretch it or compress it, it's going to make a spark. That's what I think gas grill lighters are of. They're hitting that quartz and it sparks. And what's going to put pressure, stretch it or compress it, is when those big continents were fluttering. When they were fluttering, water's going, water's building up pressure and it's fluttering. And they've noticed that there's an electrical charge during earthquakes. This is what's been documented. Flames shot out of the ground, intense electrical activity. The sky was alight, ribbon-like flashes of lightning. Bluish flames from fissures opened in the ground. Anchor chain became incandescent and partly melted. So there's some electrical activity going on inside this granite during these earthquakes. And so it's fluttering, it's going up and down depending on the pressure, and it's slamming down, causing that Z-pinch, and we'll talk about the Z-pinch later, but it's causing a lot of pressure on the granite hitting the basalt, and it's causing that spark-like thing, which could melt the granite, and it forms these chondrules, and they go down to the end, and when it finally does open up, they get shot up into outer space. That's how we get the chondrules in space. Okay, and it just keeps on going, and when that's happening, there's a lot of a lot of neutrons going on there, because when lightning hits the ground, the air kind of expands and slams together and we get the thunder. Now just imagine lightning inside of a granite. It can't expand, but it's going to slam back together, and they have this thing called Z-pinching, where you get a pure electrode material and you hit it with something going close to the speed of light. It can make 94 elements and super heavy elements. And it's radioactive, so they're unstable, so they go up and then they decay into that valley of stability. And so what's happening inside the granite is there's a lot of plasma flow, there's that expansion. It's going to take those 4 atoms and they're going to slam them into one, making it radioactive. And then again, this is just briefly, if you want more, Brian Nickel has all the math and the physics, and it's just interesting to think about. And that's why, we don't find radioactive material in the ocean. And why is it? Mainly by granite. And so with all that heat and radioactivity going on, it's going to make the crust weak, and it's just going to explode out of there. That's how you get them inland seas, I think. And I think Lake Superior might even be one of them too. I don't know. But so there's a lot of radioactivity. There's a lot of free neutrons. And what did we need in deuterium? We needed an extra neutron. That's why the comets have, their ratio is 1 to 3,200. The ocean is 1 to 6,400. And why is that? I think it's because the ocean diluted the water that was coming up. So just food for thought. And why do comets have stuff from Earth? The water, the salts, the silicates, limestone, clay. Limestone needs to be made in water, by the way. Cubonite, that's the scalding stuff. Olivine, iron, nickel, organics, amino acids, bacteria. Cellulose? That's wood. How does that happen? We had Kevin Lee talk at a Creation Club this year too, and he talked about the origin of limestone. And they had this thing called the Stardust mission. They were going to get what's in a comet and bring it back to Earth and see what's in it, so they could see the building blocks of the universe, or the Earth solar system. And he said, you're going to find stuff from Earth. And he talked to the guy, and it's really interesting. He listened to him in his own words. And so how did he know that? Well, some of the stuff, not only was it getting past our atmosphere, it got past our gravitational pull and just kept on going. And so you get the water and the dry ice and the mud going together, forming comets. And that's why the short-term comets, 93% of them are going our way. So if you were, just imagine you're on a train going 100 miles an hour, and you throw something out that's going 50 miles an hour, okay? It's all going to be going the same direction. Even if you threw it out backwards, you're going 100 miles this way and 50 miles that way, it's still going to keep going that way. That's why the short-term comets are mainly going our direction. And then if you threw it out at 150 miles an hour, well, yeah, now you're going to get more that can go the other way. And if you throw it out at 500 miles an hour, now you're getting pretty close to a 50-50 mix. So that explains it. How did asteroids get moons, which is really hard? And how do these things come together gently? Their theory is it should all break apart. But if they're all flowing together from the same place at the same speed, they're going to start to get attracted to each other. That's how you could get a moon. That's how you could get those peanut-shaped asteroids. And they've even found rounded boulders on a comet. Comet 67P, rounded boulders. What made the river rock? It was going through a flow of water, right? If something breaks apart in space, it's going to have jagged edges. How do you get something rounded in space? Had to be going through a fast flow of water, breaking off the sharp edges and getting shot into space. And so then how do you get, and Walt Brown predicted that, rounded boulders. How do you get these water canyons on Mars where there's no liquid water? Well, there's a lot of the water that went up to Mars, and it's in the soil there, and it's frozen in the soil, and if it gets hit by an asteroid or a meteor or something, it's going to generate heat, and that water is going to melt, and it's going to flow out, giving you the canyons. Okay, so now if this really happened, would it leave a mark on the moon? And the answer is yes, and it did. That's why the near side is pounded and the far side isn't. They had a rock just got released within the last 5 years. It's from the moon. They kept it hidden for 50 years. This was a rock that they picked up on the moon, and guess where the rock came from? It came from Earth. It must just be covered with rocks from the Earth up there. And they didn't release it because they couldn't explain it. It just ties it together. And these are some of the theories that, some of the predictions that he's made. And we'll just go through the ones that are right. Okay, it was verified. Pooled water under mountains, deep channels under Bosporus and Gibraltar, salt on Mars, asteroids are flying rock piles. Okay, rocks on asteroids and comets are rounded. How in the world would he know that? Water inside large asteroids, carbon-14 in old bones, and then this one too. NASA discovered Earth-like compositions of comets, fulfilling his other prediction. How did he know what was in it? Because his theory explains how it got there. Is it very good to have a comet that's going to come and destroy it, and hit the Earth? No, there couldn't have been comets and meteors and stuff that was going to hit the Earth before the fall. Everything was very good. And so this explains why there's explains a lot of it. And so one of the objections, well, the objection that I got from the professor, and there are a lot of them, and what's neat is it's all on one site. It's all on rsr.org. You can hear what the objections are to it. But what did the professor say about this? I don't believe the assumption. I don't believe there was water, half the ocean was inside the Earth. I don't believe there was water inside the Earth at that time. She didn't believe it. And my response is, why not? There's water inside the Earth right now. You get these deep smokers, these black smokers. This is hot water, super hot water coming up from the bottom of the ocean. Where does it have to come from? It has to come from below that. And there shouldn't be water below 5 miles, because when granite is under 5 miles of pressure, it kind of turns it into putty, just seals off everything. Water shouldn't be able to get through. Okay, but they dug down. In Germany and Russia, they got below 5 miles, and guess what they found? Crushed granite with water, just like the hydroplate would predict. And so if you want to get more information, I encourage going to rsr.org/answers. And these are answers to some of the objections. And even the objections themselves are published here. Wouldn't it be neat if the evolutionary textbooks would publish, have a list of published objections, so then you can see both sides? But that's what RSR does. Real Science Radio does. They want you to have all the information, and then you think for yourself. And then they answer them on the radio. Really good. Brian Nickel does such a great job with that. And for most of Walt's life, he was an evolutionist, but then he became a creationist based on the evidence and based on some of the Bible. There's verses in the Bible that validate what he's saying. To him that stretched out the earth above the waters, that's Psalm 136:6. The earth and all the inhabitants thereof are dissolved. I bear up the pillars of it, Selah. That's the pillars. It's where the granite and the basalt are touching, Psalm 75:3. By the word of the Lord were the heavens made, and all the host of them by the breath of his mouth. He gathered the waters of the sea together as a heap. He layeth up the depth in storehouses. Isn't that interesting? That's Psalm 33:6 and 7. And then, for he hath founded it upon the seas and established it upon the floods, Psalm 24:2. And then the one that we talked about earlier, in the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up. So water came gushing out of there, and now catastrophic plate tectonics, they'll say that fountain was lava. And they're really grasping at straws for that. And what they're doing is taking a secular model and speeding it up. And so if you want to learn more about that, Jane Albright does a really good job explaining. And who shut up the sea with the doors as it broke forth, as if it had issue out of the womb, Job 38:8. And it just shot out. When you have a baby, water breaks and it just shoots out. And then this is Psalm 104:5-9. The waters stood above the mountains. At thy rebuke they fled. At the voice of thy thunder, they hasted away. Could you imagine what it sounded like when the mountains were forming? And this is a psalm about that. They go up by the mountains, they go down by the valleys to the place which thou hast founded them. And some people say, that's the creation week. But keep reading. Thou hast set a bound that they may not pass over, and that they turn it not again to cover the earth. No, this is the flood. This is what happened during the flood. And then in Job, it talks about how hast thou entered into the springs of the sea. Scientists didn't know there were springs in the sea until 1977. And yet thousands of years ago, that's what Job's writing. And also Jonah went down to the bottoms of the mountains. I mean, why would somebody write, if the Bible's written by man, why would they talk about mountains in the ocean? Who would know? And so it just is strong evidence for God's word being true. And, we're going to end at rsr.org/HPT. This is what we're getting back to. There is a reason why you've never heard of it. And it's a sad commentary on Christianity. And if you want to learn more about that, go into rsr.org/HPT, Walt Brown Controversy, and listen to Jane Albright explain. She critiques all the flood models, and then she talks about the Walt Brown Controversy. And I have so much respect for what he's done, and I just want him to get the credit. So if you're interested in that, check that out. And then if you want to see the documents that they're talking about, sometimes science advances one funeral at a time, right? Like the guy who said the scablands came from a glacier flood. He was ridiculed by his peers. And then those peers died, and then now he gets the credit. Okay, and there's power and prestige and reputations at stake for this being quiet. And so if you're interested in that, and I'll just leave you with this. This is what I started with. Yeah, those are the websites. If you're interested in it, it's worthy of study, man. And I encourage you to buy the RSR tapes, those CDs. Pass it out as Christmas gifts. He is so funny. I was at a stoplight one time, and his co-host Fred Williams says, "Evolution's not a theory. It's just a low-grade hypothesis." And Bob says, "It's not a low-grade hypothesis. It's a high-grade fever-induced delusion." And that's what I did. So I encourage you. That's the best $35 you'll live. And at that point, okay, I think we're done. All right. Thank you.